Alrighty, so today we're talking about composite shapes. What I mean by a composite shape is going to be something that is a combination or a composite of two different shapes. So for example, I have this little jar thing, and what I like about this jar is this is a hexagon right here. So we actually have a hexagonal prism down here on the bottom, and then this could be sort of like a cylinder. It's not perfect, but it's kind of like a little cylinder sitting on top. So it's a combination of a prism and a cylinder. I also have this like air freshener thing. It's kind of a cylinder on the cap. Now it goes in a little bit here, so it's not a perfect composition. And then this would be maybe a square or a rectangle on the bottom, and then some kind of prism here. That's the connection. I also brought this Oberwise jar. So I'm just kind of thinking, like, if you chopped it off right here, you'd have a rectangular prism on the bottom, and then it looks like maybe a pentagon. If this were to close all the way, it could be a pentagon there. Not a pentagon, pyramid. Sorry, a pyramid on the top. It's got a rectangle base that goes up to the top. I also have this Lysol container. This one is, I don't know, it's kind of a stretch. But if we're okay with the fact that we could use this and kind of estimate, then that would be fine. And we've got, like, I don't know, maybe it's a prism down here and a cone right here, and then I take off the top and I ignore it. I don't know. So your task, and just a few things to get out of the way before I start actually measuring anything, make sure you read the rubric for, it's actually for tomorrow's assignment. So today your assignment is just to watch this video, find an object somewhere that's a combination, and then you can make the video tomorrow. Of course, you know, do the assignment for tomorrow today, and then you have tomorrow off. That's fine. Everything's posted for it. So just get that out of the way. Make sure you read the rubric. That's going to be important before you start. Okay, so in theory, I could find both the volume and the surface area of these shapes. I want to talk about this Oberwise thing for a second. We are filling ours with coins. You can see we have a few. We don't have a ton of coins in there yet. So I don't know, what's the volume of coins that I could put in this jar? What I like about volume of composite shapes is it's a lot easier than surface area, because all you'd have to do is add the two volumes. So we'd add the volume of this bottom one, we'd add the volume of the top one, we'd call it a day, we'd be done. So maybe I'll do volume first of my Oberwise container. So I need to find, there's two parts. Now, of course, you could find a composite shape that has more than two parts. That would be fine. Anything is basically a composite shape if you think about it hard enough. So volume, and then we're going to do the prism on the bottom. And we're going to do the pyramid on the top. So I'll do the prism first. Volume, we're going to take the area of the base times the height. It's kind of heavy. So this is about 5 inches by, well, we'll just call it 3.5. So I've got 5 inches times 3.5, and I would multiply that by the height. And what I'm going to be careful of is I'm really stopping my prism like here. So I'm really just going to measure maybe 7 inches tall, and I want to ignore the rest of this because that's part of the pyramid. Times 7, and my calculator disappeared, so I'm going to use my computer over here. Okay, so 5 times 3.5 times 7 is 122.5. And I measured in inches. This is volume, so it's inches cubed. Okay, there's one. It's only half of it. So now I need to measure the pyramid. Now the good news is, pyramid's using a lot of the same numbers. So the pyramid, I need my area of my base, which I said this was 5, and I said this was 3.5. So the area of my base is 5 times 3.5. I need it times the actual height and not times the slant height. So I am going to use Pythagorean theorem to get there. I'll do Pythagorean theorem this way. So this would be half of 5, which is 2.5. I need to find my slant height over here. About 4. So I'll do 16 minus 2.5. The square root of 9.75. Sorry, I really should have got my calculator. It's over in the other room. So that is 3.12 for my actual height. Okay. All right, so let's multiply these numbers together. Times 3.5 times 5 is 54.6 inches cubed. Let's add those two numbers together because that would tell me the area of my prism and the area of my pyramid. So this is 122.5. So total, if I add them together, 177.1 inches cubed. Okay, that's for volume. So it's basically the same as what we've done before. You just have to do it twice or 3 times or however it goes for however many shapes you have. Let's talk about how surface area is going to be different. We need to figure out, let's say, the surface area of glass. It's been a while since we've done surface area, but if you remember what we did before, we added kind of all of the sides that we saw. We added their areas together. But what's happening here is I have 2 shapes, and if you think about where your prism cuts off here, there is no glass. If you can imagine like cutting through the glass right here, there's no glass. So when I add all the sides of my prism, I want to include the bottom because it does have a bottom. I want to include the 4 sides, but I don't include the top because the top is not included where there's glass on this shape. So I have my numbers kind of. That was what, 5 here and 7 here. So the area of this side is 5 times 7. It's going to be the same as the area of this side. So bottom, which is a prism, we've got 2 that are 5 times 7. So 5 times 7, 5 times 7, and we've got 2 of those. This I said was 3.5 times 7. I've got 2 of those. 3.5 times 7. Now this guy on the bottom we said was 5 times 3.5. But I don't include the one on the top because there's no glass there. There's only glass here on the bottom. All right, let's talk about the top here. So if I look at my pyramid, again, same thing. There's no bottom of your pyramid, so you're not going to include the glass that's right there. We're just going to include that thing we called the lateral surface area way back when. So I really have triangle 1, triangle 2, triangle 3, and triangle 4. So I've got 2 triangles that are the same, 2 triangles that are the same. Okay, so let's see. How do I want to do this? This is, I said 5, and I need the actual height, which is the slant height. So that we said was 4. On this side was 4. This side it's going to be a little bit shorter. This is about 3.25. So for this triangle, I'm going to have 2 of them because I have this guy and that guy. I have 5 inches across here. I have a slant height, I said, of about 3.25 over 2. 1/2 base times height, base times height. Okay. So I guess the 2's really just cancel out. Same thing over here. I'm going to have 2 of them. That was 3.5. My base. My slant height, I said, was 4. Divide by 2. Those are going to cancel out. So that's going to be the area of these 4 triangles on the top. So I need to do a little bit of calculations, and then that's going to be the end. I'm not going to do it since my calculator is gone, but add, I mean, you're going to have this guy, this guy, this guy. I have 5 numbers here. Add them all up, and you'll get your total. It's going to be in inches squared because it's surface area. Okay. Again, make sure you read the rubric before you begin the assignment, and have a wonderful rest of your day.